For more than 100 years, cars have been built almost the same way. Thousands of parts, endless welding, giant factories filled with robots, sparks, conveyor belts, and workers repeating the same process over and over again. It became so normal that nobody questioned it anymore. Then Tesla started building a machine so extreme that even people inside the auto industry thought it sounded unrealistic. A machine with enough force to crush entire structures shut, while molten aluminum exploded through massive molds at terrifying speed. Not 10 tons, not 9,000, 50,000 tons. And according to Elon Musk, this machine could completely change how cars are made by 2027. But the strange part is, Tesla may not just be trying to build cars faster, it may be trying to eliminate most of the factory itself. That idea sounds impossible at first, because modern car factories are incredibly complicated. Even today, most vehicles are made from hundreds of separate metal pieces. Every panel is stamped somewhere else. Every frame section is welded together step by step. Tiny components are bolted into larger structures until eventually a full car appears at the end of the line. It's slow, expensive, and unbelievably inefficient. But for decades, automakers accepted that complexity because there was no other option. Or at least that's what everyone believed. Then Tesla quietly changed something that most people never noticed. Back in 2020, Tesla introduced a massive 6,000-ton GigaPress machine for the Model Y at first. It sounded like another technical experiment. Industry headlines treated it like an engineering curiosity. But inside Tesla's factories, something far more important was happening. Instead of building the rear section of the Model Y from dozens of smaller parts, Tesla started making it as one giant piece. One casting, one shot. Suddenly, parts that once required entire teams of robots and long welding lines simply disappeared. And the effects were immediate. The car became lighter, stronger, faster to produce. Factory space shrank. Manufacturing costs dropped dramatically. Tesla didn't just improve production, it removed entire steps from the process. Steps that traditional automakers had spent decades optimizing. That's when a few engineers inside competing companies started realizing this wasn't a gimmick. Because if Tesla could replace 70 or 100 parts with one giant casting, what happens when that number keeps growing? At the time, most competitors still weren't worried. A 6,000-ton machine was already enormous. But companies like Toyota, Ford, and Volkswagen believed Tesla was taking unnecessary risks. Traditional manufacturing had worked for generations. Why rebuild everything around giant aluminum castings? Why gamble an entire production system on one machine? Then Tesla made another move. For the Cybertruck, the company pushed even further, introducing a 9,000-ton GigaPress. And this changed the conversation completely. Because now Tesla wasn't just simplifying small sections of vehicles, it was proving larger structures could also be built this way. Bigger castings, fewer joints, less welding, faster assembly. Suddenly, the question inside the industry shifted from, will this work? To how far can Tesla take this? And that's where the story starts getting uncomfortable. Because while most automakers were still trying to improve traditional factories, Tesla appeared to be moving toward something entirely different. A future where huge sections of a vehicle, maybe even most of the structure itself, could be formed in a single process. And according to Elon Musk, the next step would require a machine so powerful that almost nobody in the industry had ever attempted anything close to it. 50,000 tons. To understand how extreme that is, you have to understand what those numbers actually mean. The machine itself doesn't weigh 50,000 tons. The number refers to clamping force, the pressure used to keep gigantic molds locked shut while molten aluminum is injected inside at incredible speed. The force is almost impossible to visualize, roughly equal to dozens of fully loaded airplanes pressing down at once. And Tesla reportedly wants to use that pressure to create castings far larger than anything seen before in mass production. That's not a normal upgrade. That's a completely different philosophy of manufacturing. Older GigaPress machines could inject around 100 kilograms of molten aluminum at once. But a machine at this scale could potentially push several times more material into massive molds before the metal cools, which means larger structures can be created faster, with fewer weak points, fewer assembly steps, and dramatically lower production costs. And this is where the real threat begins, because the machine itself isn't the most important part. The economics are traditional automakers operate enormous factories designed around old manufacturing methods. Thousands of workers, miles of conveyor systems, giant welding departments, huge inventories of separate components arriving from suppliers every day. Entire business models built around complexity. But if Tesla can replace hundreds of pieces with just a few giant castings, those old factories suddenly become painfully inefficient. Imagine two companies building electric vehicles. One company assembles 300 separate components together using massive labor, huge factory floors, and long production lines. The other creates giant sections in one shot using a handful of ultra-powerful machines. The cost difference becomes impossible to ignore, and this may be why Tesla is moving so aggressively towards cybercab production. Because robotaxis only work economically if manufacturing costs collapse. The vehicle has to become cheap enough to produce at massive scale, which means reducing parts, reducing labor, reducing time. The entire strategy depends on simplifying the car itself. But there's another side to this story that Tesla supporters rarely talk about, because giant castings create giant risks. If a small traditional component fails, it can usually be replaced cheaply. But if one massive casting develops a defect, the loss becomes enormous. Entire sections may need to be scrapped. Repairs become harder. Insurance costs could rise. Even tiny air bubbles or cooling problems inside giant aluminum structures can weaken the entire part. And some manufacturing experts believe these problems become much harder to control as castings increase in size. That means Tesla may be solving one problem while quietly creating another. And yet, despite all those risks, the rest of the industry may not have much choice anymore, because by the time traditional automakers fully react, Tesla could already be operating factories built around an entirely different production system. Chinese EV companies are moving quickly too. Some are already investing heavily into gigacasting technology, trying to compress production times and lower costs before the rest of the market catches up, which creates a dangerous possibility for older automakers. What if the factories they spent decades building suddenly become outdated? Not because they stopped making good cars, but because someone discovered a faster way to manufacture them, and that may be the real story behind the 50,000-ton GigaPress. Not the machine, not the engineering, not even Tesla itself. The real story is that the auto industry might be entering a moment where manufacturing becomes more important than the product. A moment where the company that builds vehicles fastest and cheapest wins everything. Because if one machine can remove hundreds of parts, thousands of welds, and entire sections of a factory, then the real question isn't whether other companies will copy Tesla. The real question is, what happens if they can't? That fear is already starting to spread quietly across the industry. Because once you understand what Tesla is really attempting, you realize this isn't just about building electric cars anymore. It's about rewriting industrial manufacturing itself. And companies that spent decades perfecting the old system are suddenly being forced to question whether all that experience still matters. Think about companies like Toyota or Volkswagen for a second. These are giants. Their factories are some of the most advanced industrial systems ever built. Entire cities depend on them. Millions of jobs were created around their manufacturing processes. Suppliers, logistics networks, welding systems, stamping plants, everything evolved together over generations. The complexity became part of the business. Then Tesla arrived with a completely different mindset. Instead of asking, how do we improve the process? Tesla started asking something much more dangerous. What if most of the process shouldn't exist at all? That question changes everything, because once giant castings replace hundreds of individual components, entire layers of manufacturing suddenly disappear. Fewer robots are needed. Fewer welds, fewer workers moving parts from one station to another. Even factory design itself begins changing. Production lines become shorter. Warehouses shrink. Supply chains simplify. And that creates a brutal economic advantage. A traditional automaker might spend years coordinating thousands of suppliers to produce separate components for a vehicle. Tesla's approach moves in the opposite direction. Reduce dependency, reduce steps, reduce complexity. It sounds simple when you say it out loud, but inside the auto industry, this is almost like questioning gravity. For decades, large automakers believed complexity was unavoidable. That's why factories became larger and larger over time. More departments, more systems, more coordination. But now, Tesla is moving toward something strangely minimalist, fewer pieces, doing more work, and competitors are running into a terrifying reality. They can't adapt quickly.